Subject Chemistry, Class First Year, Chapter number 2, Atomic Structure, page number 31, topic The Discovery of Proton. Bismillahir Rahmanir Rahim. Positive rays and discovery of proton. First, introduction. Atom as a whole is neutral, but electron has a negative charge, so a positive charge particle is also present in atom, which cancels the effect of the negative charge particle. Having this concept in mind, Goldstein was the first scientist who discovered proton. The stepwise detail of his experiment is given below. First step, experiment. Goldstein modified discharge tube having perforated cathode, means holes in cathode. The small holes in the cathode were called canals. Discharge tube was filled with a gas, and pressure inside the tube was reduced with the help of vacuum pump. After reducing pressure, the electrodes were connected to high voltage source battery. Step 2, observation. He observed that some rays other than cathode rays traveling from anode towards cathode and passing from canal of cathode. The rays caused a glue on the wall opposite to the anode. The rays caused a glue on the wall opposite to the anode. He called them canal rays because the rays were coming from the canals holes in the cathode. Step 3, origin of anode rays. Goldstein concluded that anode rays not actually arise from anode, but when high-speed cathode rays strike with gas molecule present in the discharge tube, they knock out one or more electrons from it. After removal of electrons, positive ions result which move towards cathode and passed from the holes of the cathode. Step D, conclusions from properties of anode rays. These rays travel in a straight line perpendicular to the anode surface. These rays are perpendicular to the anode surface. Anode rays are material particle in nature because causing mechanical motion of small pinwheel placed in their path. It means anode rays are particles. Anode rays are positive particle because deflected by electric and magnetic field in opposite direction to electron and attracted by cathode. Deflected toward negative electrode. Produce fluorescence when strike with zinc sulfide layer. The charge to mass ratio is smaller than electron and depends upon the nature of gas used in the discharge tube. The maximum charge to mass ratio 9.54 multiplied by 10 to the power 7 coulombs per kg is obtained for hydrogen. The charge is found to be equal but opposite of electron. Why charge to mass ratio of electron is greater than proton? If we check carefully, the magnitude of the charge of electron is equal to that of proton, but the mass of electron is less than the mass of proton. So when we divide this figure on smaller number, we will get higher value. But when we divide same number by greater number, we will get small values. This is the reason that charge to mass ratio of electron is greater than charge to mass ratio of proton. Second important point, the maximum E over M ratio is obtained for hydrogen. Why? We know that hydrogen has only one proton in the nucleus. So when hydrogen ionizes, there will be only one proton. It means the mass of one proton. If we take other gases, for example, helium, we know that helium has two proton and two neutron. So when ionized, there will be two proton and two neutron. The mass of two proton and two neutron is greater, so A over M ratio will be small because we have to divide charge on mass, and the mass of two proton and two neutron is greater than hydrogen. These positive rays were named proton. The charge on proton is this, and mass is 1.6726 multiplied by 10 to the power minus 27 kg. Proton is 1836 times heavier than electron. When we divide mass of proton on mass of electron, we get 1836. It means this is the mass of proton divided by mass of electron. We get 1836. It means proton is 1836 times heavier than electron.